Okay, so another AC series parallel circuit. We have voltage of 15 at 10. The first circuit that's with the voltage is in parallel, so you know you're going to wind up with a parallel circuit. Then you have 3K ohms at negative 90, so you already have capacitive reactance. You have 500 ohms at 90, so you already have inductive reactance. You have a resistor here, and you have a capacitor here with capacitive reactance. So remember, you always work the furthest point towards the circuit, okay? So the first thing we see is 2K in parallel with 2K at negative 90. So you're going to note that. 2K in parallel with 2K at negative 90, right? Because they're in parallel together. They have 2 points in common. That's how you know they're in parallel, right? When you get that parallel combination, you're going to get 1.414K ohms at an angle of negative 45, right? So that's doing the parallel combination here. Remember, with the parallel combination, you're not adding them, you're getting the reciprocal. So then you would redraw the circuit, and this would be added here in a box. Well, I've already pre-done this, okay? And I have, so when I added these two, it actually goes here, 1.414K ohms at an angle of negative 45. That's these two in parallel. Now what do we see? We see these three are in series, because how many points in common do they have? 1. So when you add 3K at negative 90, 1.414K at negative 45 plus 500, you get, and you can note it down here so we can write it, 3K at negative 90 plus, this signifies that it's in series, and the parallel signifies that they're in parallel. 1.414K at an angle of negative 45, also in series with 500 at 90. Okay, so those three are in series. When we add them up, we should get 3.64K ohms at an angle of negative 74.06. That's when we add those three up. Okay, so basically all we did was add them up, and now they're going to be in parallel with the 2.5K ohm. And there's that. So this 3.64 goes here, 3.64K ohms at an angle of negative 74.06. So what do we have now? We just have a regular parallel circuit. Do you have to break this circuit down any further? Absolutely not. We know that what's constant in a parallel circuit is voltage. So we know you have 15 at an angle of 10 volts here, and 15 at an angle of 10 volts here. We do want to get I total, so we should get the Z2 by doing the parallel combinations, but you do not have to rewrite that. So Z total here would just be putting the 2.5K ohms in parallel with 3.64K ohms at an angle of negative 74.06. So Z total is 1.839K ohms at an angle of negative 29.06. That's our Z total. Why is that important? Because we need to make sure that I total coming into the circuit has to equal these two. These two have to equal the I total. So to get the I total, it's 15 at an angle of 10 divided by Z total to get an I total of 8.16 milliamps at an angle of 39.06. So right now we have an I total of 8.16 milliamps at an angle of 39.06. We have that coming in. Once it hits this point, some current comes down. Then the rest goes around, they meet, and they go home. So to get the current here, it's E divided by R to get that current. You should get 6 milliamps at an angle of 10. 15 divided by this gives you 4.12 milliamps at an angle of 8406. This current plus this current must add up to this. Once you know that that is correct, right, then you can go back. The first thing you have to go back to is this, 3.64, which is here. This is the voltage across. This is the current through. It's going back to a series circuit, so this current would go back here, here, and here. So you're going to multiply all of these by 4.12 milliamps at an angle of 8406. All three of these get multiplied by that to get their voltage drops, and their voltage drops must add up to where it came from, which is this guy, so they have to add up to 15 volts at an angle of 10. The voltage here is 12.36 at an angle of negative 5.94. The voltage for the 1.4 is 5.83 volts at an angle of 3906. The voltage for the 500 at 90 is 2.06 at an angle of 17406. You make sure that you add them up, and they add up to where it came from, which is 15 at 10. Last but not least, how did we get this 14.14, right? Or 1.414. We did the parallel combination. What's constant in a parallel circuit? Voltage. So this voltage from here goes here and here, which is 5.83 at an angle of 3906 here, and 5.83 at an angle of 3906 here. So that's their voltages. We have to get their currents, and their currents have to add up to where it came from, which is here, 4.12. So when you take E divided by R, you get 2.92 milliamps at an angle of 3906. When you take E divided by C, you get 2.92 milliamps at an angle of 12906. And that's it. You got all voltage and current for everything. Have a nice day. Be safe.